Can you imagine a minor coding mistakes may cost millions of dollars? Don't believe me? Wait and watch. In this video, I will share 5 minor coding mistakes with real life examples from history that has cost millions of dollars. And these mistakes may stop you to become a pro coder. So let's start with the first one. The first one is hard coding values. In very simple words, hard coding values make the code less flexible and very hard to maintain in long run. Hard coding values such as error codes, database connection strings, and fixed configuration values can lead to maintainability and security concerns of any project in long run, and it might have a huge impact. For example, Cisco faced significant security issues with its emergency responder product due to hard-coded root credentials. An attacker could exploit its vulnerability by using the account to log into an affected system. But of course, Cisco discovered the issue during internal security testing and had to release an update to resolve the problem. These examples clearly highlighted the security concern of using a hard-coded value. So we must avoid hard-coding values in our product. And it's super easy to avoid hard-coding values by using configuration files, environmental variables, and other dynamic methods. And of course, it's really important for developing a robust and secure application. And the next one in my list is poor version control practice. Poor version control practice can make the whole process very messy. This can cause conflicts, lost code, and trouble keeping track of changes. So a good version control is really important for keeping your code organized, making it easier to team members to work together, and ensuring you can really track and manage your changes. So what exactly poor version control practice? Basically 3 main things. The first is lack of branching strategy. Second, bad or no code review. And third, infrequent commits. Now let me share an example from history. Insights from Toyota's unintended acceleration case. First, the codebase was overly complex and untestable. And of course, it's increasing the risk of introducing new bugs when making any change. And the other part is about bad code review. Absence of peer code review and Toyota's failure to check the source code of its second CPU. And of course, it's really easy to adopt best practices like create separate branches for new features, bug fixes, and for experimental work. And of course, once your work is complete, merge these branches back to release or main, depend on your workflow. And instead of committing a large chunk, commit small incremental changes after every few hours. And the next one in my list is inadequate testing. Inadequate testing is very common in software development, and it can lead to undetectable bugs, poor user experience, and costly fixes down the line. So in very simple words, it may result in unreliable software. Let me share another example, and the company has lost millions because of inadequate testing. Knight Capital lost for 40 millions in 30 minutes due to something the firm called a trading glitch. In reality, poor software development and testing models are likely to blame. And the root cause behind this? The standard rush to production without proper testing. Proper testing ensures that the software works as expected under various conditions and edge cases. Now the next question you might have as a developer, what kind of testing you should focus on? I believe 3 kinds of testing. The first is unit testing. Unit tests for individual component or functions to ensure they work as expected. And the second is integration testing. Integration testing verifies that different modules of services interact correctly. And finally, automated testing. You can use tools to automate repetitive tasks, increasing coverage and reliability. And the next one, and probably one of the most important one, is ignoring error handling. Ignoring error handling can lead to critical software issues. Proper error handling ensures that application can gracefully recover from unexpected situations and provide meaningful feedback to users. Let me share a real example from history. It's about Ariane Flight V-88. Was the failed maiden flight of the 4th of June 1996. It carried the cluster spacecraft. The launch ended in failure due to multiple errors in software design, with inadequate protection against individual overflow led to an exception handled inappropriately. And it's classified as the worst computer bug in history, losing 460 millions in 45 minutes. As I mentioned earlier, it failed because of multiple software issues, and one of the issues was the specification of the exception handling mechanism also contribute to the failure. These examples highlight the importance of robust error handling in software system. And the next one is not following coding standards. Coding standards are a set of guidelines and best practices for writing code. They ensure that the code is consistent, readable, and maintainable. Ignoring these standards can lead to code that is difficult to understand, prone to errors, and challenging to maintain or extend. And by following simple best practices, you can ensure that codebase remains clean, consistent, and maintainable, leading to a high-quality product. Let me quickly share 3 best practices which you can use right now. The first is consistent naming conventions. Second, conduct regular code review. Finally, clear and concise documentation. And here by clear and concise documentation, I don't mean you have to write hundreds of pages of documentation. In fact, your code speaks and there are better ways to document your code. And if you want to learn more about it, here is a video for you. Top 7 ways to document your code. I hope you will enjoy this video and thank you for watching.